Hi, welcome back to my channel, Make It in Solidworks stroke Rhino, and this is a continuation of the Rhino modeling course which I'm doing with my students. So in this one I want to explain a little bit about sketches for modeling and the best practice and why you have to do it this way. So I'm going to show you just the basics of Rhino. Rhino is a NURBS program. That's a non-uniform rational B-spline program, which means, as you can see here, I can lay down control points. That's what, every time I click my mouse, I get a control point. And I get these control points here, which influence what the curve looks like. So if I wanted this to be a nice, neat S-curve, I'd have to do a bit of work in altering where these lie. Okay. And so this is really quite tedious and doesn't give me a readily smooth curve. So there's a better way of doing this, and this is the power of NURBS, is that you can take a curve and you can change both the number of points in it, the number of control points, and the degree to which those points influence the curve. So currently, whenever I do a rebuild, whatever's in brackets is what I currently have. That's 2 points and at 1 degree. I'm going to create one with 10 points. That's just to show you a little bit later how we can create the S-curve, and then 1 degree of influence. So if I click one, okay, and I select one of these points, you'll see when I drag it out, I get straight lines between these various points on the curve. That's because there's just 1 degree of influence between one point and another. If I change this degree, the degree of this curve, and I say change degree in the command line, and I'm going to change it from 1 to 3, because we usually work in 3 degrees. All right, so now if I select a point, you'll see that it has 3 degrees of influence, which is like 2 points of influence. So if I drag this out very, very far, you'll see that the most points that are influenced are this first one and the second one, and then the third one is not influenced. So if I wanted to create a curve of an S nature, I would just drag those two out. I probably have too many here, but you can see this is a much smoother curve than the one I had before, and it's much easier to control. Okay, so that's basically what we're going to be practicing in our modeling, something like this. Now I'd like to show you how continuity works, and for that, for me to show you that, I've just moved across to this next layer, which is G0, and I have these two curves which are touching one another. I know they're touching one another because if I join them, you'll see that they create a single open curve, and I can explode them, and I'll have 2 segments. If they weren't touching one another, they would not actually do what I've just shown you. So we can test to see what the status of the join of a curve is by going to this tool here, which says geometric continuity of 2 curves. I click on it, and I click on one item and then the other one. It'll tell me in the status bar that the curves are G0. Okay. The other way we can look at this is to apply a curvature graph to it, right? And the curvature graph displays the rate of change of curvature along a curve. All that means is that these vertical bars, or these bars which are perpendicular to the line which they describe, would remain the same if the rate is the same. If the rate was to change, you'd see those things change. Okay, let's have a look at G2. Okay, so here is G2. I've got these 2 curves. And now I'm going to put in a fillet, which means I'm going to get a tangency relationship. So 10 between that line and that line. Let's do that again, between that line and that line. So these are not joined together, but because they are connected at those, or that they touch at those points, I can join them. There we go, and I've got an open curve. And I can test now for continuity as well by going back to this command. It's going to ask me for two curves, 1, 2. Curves are G1, and I can do that again at the top. These two are G1. G1 means tangency. Let's have a look at what happens when we put a curvature graph on. We'll see now that the rate of change of curvature for my original two curves is the same, but the rate of change of curvature for that new fillet is much greater. You can see that the length of the curves is much greater, but the rate along that curve remains constant. In other words, every single one of these lines here is the same length. Okay, so let's hide that and go to G2. Now I want to do the same thing. I want to create, but instead of doing a fillet, in fact, I'm going to do a fillet now just to get our starting point. So what I want to get a continuous curve between these two, in which the rate of change of curvature makes like a curve. So this is not the correct way of getting an equivalent curve. I'll have to show that to you later. But I'm going to use this adjustable curve blend tool, and I need to make sure that it says on the blend start that curve end is selected, not pick point. Otherwise, I'm not going to get the end point. So from this line to this line, and what you should notice now is that I've got 1, 2, 3 points on one side of the curve and 1, 2, 3 on the other. Let's just go back and show you the difference between that and this curve here. This one has just 1 point in the middle and then 2 points marking the ends of the curve. That's because the minimum number of points that you need to create a curve of any sort is 3. So you'll notice that this curve also has 3. It has 1, 2, 3, and then that one would have the same. So let's go back to our G2 continuity and have a look at what happens with the curvature graph on. All right, currently it's not showing a continuous curve. I think that might be because, let's first of all check this geometric. So this is a single curve. It's exploded that. So it's 3 points, 3 curves, sorry. And then the continuity of 2 curves should be G2 now. And there you see, curves are at G2. And I'll do the same for those 2 curves. And those also at G2. So if I now select these and I put a curvature graph on, you'll see that the rate of change, pull that out the way, is constant up to this point. And then there's a much more gradual rate of change on this blend curve. So it's not quite continuous yet, but it is much more gradual. So if I did that again, and this time when I select these 2 curves, I have a curvature of G2, but let's try with G4. I'm going to go straight to the extreme, and you can see that the graph itself becomes more continuous the higher up I go as far as influencing is concerned. But this is just to illustrate. We're not really going to use G3. I'm going to switch this off. And now just to show you the difference in what happens when we extrude this, because that's the whole point. So let's take these 2 curves and extrude them. And then we're going to apply to this surface this tool here, which is the zebra analysis. And in zebra analysis, you get these stripes which help you to see what's happening where the 2 planes meet, or the 2 surfaces meet. So at the moment, because it's G0 continuous, they're touching, but that's it. So the lines are in a similar direction, but they're not the same size or shape, and they're not connected to one another. Let's try and see what happens when you go to G2, or G1, sorry, not G2. just delete these two and extrude this surface out, and you'll see how great, nice and smooth it is. Let's put some stripes on it and see what happens. So you'll see now that the stripes are connected to one another. Even if they don't blend into one another smoothly, there is a very sharp transition from the top surface to the fillet and then back to the lower surface. And that transition is what you can use to detect whether you have G1 continuity. So let's go on to G2. Switch that one off. Right, so I can see it's G2 because of how many points I have here. Extrude that out. Add these objects, and you can see now that the stripes meet the blend in a smooth way. At the moment, I might have to just adjust this mesh. Let's see if that makes a difference. It's not going to make a difference. Anyways, that is going to be much smoother in real life. There's another way we can test this. We can go to the, where is it? It's this one, environment map, and we can apply a map to it. So you can select different maps. You can select, say, polished silver, and you can get some idea of how smooth your curve is, or your surfaces are. Right, so thanks for watching, and I promise in the next video we will begin modeling.